there, this is, whoopsies, there we go, probability video 6. So the last video, the questions were, sorry about the background noise, the questions were pretty easy. There wasn't a whole lot of difficulty in figuring out the sample space, and heck fire if you could write. I'm sorry, I don't know, I think they're emptying the garbage next door. It wasn't too bad, but some of your questions are going to be like that, but some of them are going to be using the fundamental counting principle, combinations, permutations, whoopsies, from last chapter 2. So there's going to be a mix of them. So you want to make sure you can handle both. That's why we have these ones, which are practice, which are a little bit more challenging. All right, Fred, Barney, and Bert are competing with 7 other boys on a cross-country team. All the boys have an equal chance of winning the race. Determine the probability that Fred, Barney, and Bert will place first, second, and third in any order. Okay, so what do we got here? First of all, there's 10 boys on the team. Now, my first thought was that was going to be my sample space, but not so much, because it gets complicated. Here, we're talking about placing first, second, and third in any order. So we're looking for the 3 winning boys. So, and it's not going to be 3 on the bottom either. It's going to be, oh, right there, right there, right there. There's your hint. In any order. So order doesn't matter. So that means I'm going to have a combination. So my bottom number is going to be a combination that's going to be, there's how many boys? There's 10 boys. And we're going to have to choose any 3. All right. This is for the top 3. Doesn't matter. Now, we want to have Fred, Barney, and Bert come in first, second, and third. Order doesn't matter. So we're going to have, there's 3 of them, and we want to choose all 3. I'm just going to let the big old garbage truck go by. There it goes. All right. So as he's making that noise, I will come close to the mic. Let's do a quick recap. 10 boys. That is my N. I have to choose 3. So any 3, that's our sample space. But specifically, we want to know the probability of Fred, Barney, and Bert placing first, second, and third in any order. That's where there's 3 of them. We want to choose 3 of them, all 3 of them to win. So we choose 3. I'm pretty sure that should be 1. There's like one way those guys are going to do that. Over 10, choose 3. 10. 120. And it's 0.0083. I know I say round it to decimal points, but that's why it's important to have this answer. Because if I round it to 2, it's going to be 0.01. I should say 2 significant figures, but let's not worry about it. Let's make sure this is right, and then this is fine. Okay, now, if just random question, if we wanted them in this order, Fred first, then Barney, then Bert, then order would start to matter, and you'd be looking at permutations. But we just need to, because order doesn't matter, we can use combinations. All right. Ernie is having a contest. I think you guys should try these on your own. So feel free, pause it, give it a shot, and then turn the video back on, or maybe even check the answers first and see if you got it right, and then be happy. And if not, then come back. Maybe there's a mistake in the answer key. Maybe it's me. Oh, hold on. Sorry. Okay. Anyway, getting back to the question. Ernie is having a contest. He spelled out Saskatchewan in Scrabble tiles. He turns the tiles upside down and mixes them up. Ernie promises to give you a new car. Woo! If you arrange the tiles in a row and they sell Saskatchewan when he turns them over. What is the probability that you win? Okay. Well, I think we need to worry about how many different ways we can arrange Saskatchewan, because that's going to be our sample space. And the correct way. So the problem, or I don't know if it's a problem, but what we have to watch for is Saskatchewan. Okay, so since we're looking at spelling it right, then order matters. So that means we're in permutations. And if you look here, Saskatchewan has got some repeats. So we need to figure that out first. Let's figure out all the different ways that we can rearrange the word Saskatchewan. So there are 12 letters. This is, by the way, in case it's been a while, the n factorial over r factorial, s factorial, t factorial, that one, because we have repeats. So there's 12 letters altogether. There's 1, 2, 3 A's. Oh, okay. I'm going to change here so this is all in capitals. So I can say there's 1, 2 S's. And that's all my duplicates. Okay. It should be like that simply because I want to make sure that this S and the little s are interchangeable. All right, so 12, oopsies, 12 factorial divided by 3 factorial divided by 2 factorial. Oh my, 3, 9, 9, 1, 6, 800. Seems familiar from doing that question before. All right, so I guess for a question, there's one correct way. There's my answer now when I do the question. All right, 0 decimal. You see that? 1, 2, 3, 4, 5, 6, 7. 1, 2, 4, 5, 6, 7, 2, 5. There we go. See, this would be one of those questions where I have to be careful and say, if I round it to 2 decimal places, the answer would be 0. So chances are pretty slim that Ernie would have to buy you a new car. You could probably buy insurance for that. I actually looked that up. I wasn't thinking of this question, but I know that when you guys have golf tournaments, you can actually buy insurance against somebody winning a hole-in-one. And it can cost a lot of different variables. So pros. Sorry, I'm getting off topic. Google it. It's kind of interesting. All right, next 2 questions. In the game Crazy Eights, players are dealt 8 cards from a standard deck. Determine the probability that the hand will consist of 8 hearts. So let's just figure this out. Oops, I should put probability here. All right. You don't need to do this part, but it just helps me organize it and it helps, I hope it helps you guys. So I've got 8 cards. Now, if I'm talking about hands of cards, is that permutation or combination? I'm hoping you're saying and or thinking combination, because order doesn't matter. Because if you've played cards most of the time, first thing you do is you pick up your cards and then you start arranging them, right? So the original order doesn't matter. So it's going to be a combination, and I need 8 cards. And if they have to be hearts, that means it's going to be 13, because there's 13 hearts. Now, all hands, well, I'm still giving you 8 cards, so I still get to choose 8, but there's 52 cards altogether. Now, I'm going to see what I can do about doing this on the calculator all at once. 13, choose 8, divided by 52, choose 8. Oh, okay. 0.1, 2, 3, 4, 5. 1/7. There we go. You know, it's not too likely. That makes sense. All right, there we go. I guess you could have done them each and then put the numbers, but this is enough for me to know what's going on. Last one. Oops. Oscar needs to create a 4-digit password. Okay. Sorry, there's some pronoun issues here. That's what happens when I change. Anyway, it doesn't matter. Okay, Oscar needs to create a 4-digit password to access his voicemail account. He can repeat some of the digits, but all 4 digits cannot be the same. Okay, so I could be like, okay, so first thing, remember, boom, 4 digits. Can't use a 0 at the front. Okay, got to remember that part. And some of the digits can be the same, but not all. So I could have 3, 3, 3, 9, not 3, 3, 3, 3. Okay, well, this is different. I've never seen this one before. Determine the probability his password will be greater than 5,000. Okay, so 1, 2, 3, 4 digits. I love my sample spaces. All right, now we need greater than 5,000. So I know 0 is not going to work. And then 1, 2, 3. Those ones won't work either. Because, for example, this number is not greater than 5,000. Or if I have 4, 9, 9, 9, that's still not. So it can't start with those. So that leaves me 1, 2, 3, 4, 5 choices there. I think there's probably a really fancy math way to do this part, but I'm going to cheat a little bit. Oh, by the way, this part, I guess, is our event. I'm going to ignore this part about the 4 digits cannot be the same because, check this out, we'll deal with that later. Okay, so we had a 5 there. We can have anything here. Oh, sorry. So that's going to be 10 choices, 10 choices, 10 choices. Now, I'm going to worry about this part. So if we go over 5,000, wow, why is there so much noise out here today? Sorry, if we go over 5,000, the only time 4 digits are going to be the same is you're going to have 5, 5, 5, 5. Oopsies. Right? Those are the only times. So we can't use these numbers. So if we figure out this answer and then subtract 1, 2, 3, 4, 5 from it, we got it. Because I'm not 100% sure how I would do this part. I might try it later and see if I can figure it out on my own. But let's just make it simple. So 5 times, oh, really? It's going to be like 5,000 minus 1, 2, 3, 4, 5. There's our event. Now, our sample space. One, 2, 3, 4. Okay, being lazy. Didn't feel like writing it out this time. It's easier. All right, so this is any number. I don't have to worry about this because this is our event. We want sample spaces. So we're looking at all 4-digit numbers, except the ones that are the same. And again, I'm going to do exactly the same thing. We're going to deal with that later. So my first spot, though, we know can't have the 0. So it's going to be 9 and then 1. Those are all going to be 10s because anything goes. But which ones do we have to adjust for? Let's see. 1. I have to take those out because can't have 4 digits the same. So, oh my goodness, did not leave enough room here. I'm sorry. And I'm really sorry about the background noise. So it's going to be 9,000 minus, there's going to be 9. Because it's going to be the 1s, the 2s, all the way up to the 9s. Okay. So my final answer, and I'm going to double check this with my answer key, should be but I'm going to double check this because I got this from a different source than I usually do. And this one seems valid, but I keep thinking the answer I picked. Anyway, check the answer key. This looks pretty good. And have a lovely day. Now you get to see me mess around, not being able to see my mouse because I'm outside. And for those of you who are thinking, why doesn't she get a trackball? Oh, yeah. Use it. All right, can you use this? I'm sorry. Oh, I'm so embarrassed. Come on. There's my mouse. There it is. Come on.